Complex numbers, day number 2. One type of example, okay, with 2 subtypes. All right. Before we roll with the problems, we need to go this definition first. Complex conjugates. Complex conjugates. Definition is this: they are 2 complex numbers of the form a plus bi, a minus bi. One is a plus bi, the other is a minus bi. A and b will always be numbers, okay? I is the imaginary unit, so that means the only thing different between the two is the what? The sign in the middle. Alright, the plus and the minus. Okay, now not the first question that we do today, but one eventually, the second question we do, and then the 2 after that. You will need to know what a complex conjugate is in order to do it. Okay. The first one, what I dropped? Oh, just my marker. But the first one you don't. Okay. First one you do not. A little side note with these, you can use the product. I'm getting there. The product of a complex conjugates is always a real number. So you're turning 2 complex numbers, multiplying them together into a real number, which is slick. You can use this to help simplify the quotient of 2 complex numbers. Okay, now, your first example. 4 plus I over 5i. Now, you may or may not have been told this. Okay, so I'm going to tell you now. At some point in your life, you need to I don't know where I was going with that. That was a terrible example. Let's go with this. At some point in your life, you were probably told whenever you're doing a square root part, square roots, that you cannot have square roots in the denominators of fractions. Anybody been told that, / remember that, / don't know, / anything?
I was told that 5 seconds.
Fantastic. You cannot have square roots in your denominators of fractions. All right, it's not proper. Now, since i's come from square roots, you also cannot have i's in the denominators of your fractions. Okay? So that's what we have to work with now. We have to try to get rid of that I in the denominator. All right, and here's how you're going to do it. Much like how you can multiply 1/2 by 2 over 2 to make it 2/4, right? To change a number. Okay, we've done that before at least. I know that. Much like how you can do that on this guy also. Except instead of doing it by 2 over 2, I'm going to do it by I over I. Okay? Times by I over I. Which is going to be I times 4 plus I over 5i times I. Alright, the blue I here times this quantity up here. This I down here, blue I times the 5i. Okay. Now up top here you're going to do what? Starts with a D. Distributes. The bottom you're just going to multiply. Okay, so distributing the top now. I times 4 gives you 4i plus I times I gives you I squared over 5i times I gives you 5i squared. Good. Your next step is going to be clean up your I squares, because we all know that I squared is -1. Good. So we have equals 4i plus a -1, so just -1, all over 5 times -1 gives you -5. Now that is almost a right answer. There's one thing that makes that not a fully right answer. The negative at the bottom. Very good, Miss Pearson. Okay? Can't have a negative in the bottom. So what you do, it's really easy. You go through it, you change all three signs. Okay, so you go negative 4i plus 1 all over 5. That's a good looking answer, kiddos. Now, if you get to here and you forget to do that sign changing, all right, no, you're talking about losing half a point. Okay, I don't want to say it's not a big deal, but it's not vital to the problem and to the process that I want you guys to know. So if you get to here, you're talking about minus a half, but this will get you full correct. Next example. 2i over 3 plus 6i. 2i over 3 plus 6i. What's different about this problem from last? How does it look different? It's flipped. How so? Well, it's not supposed to be, but it is, right? Okay, that's just the way it's written. All right, which is fine. You can see problems like this. Okay, there's nothing like we don't have to flip it. But you see how you have one term on the top now and 2 on the bottom? Okay, that's going to change your process just a little bit. All right, because think about the process we just finished. If we were to take this problem and do it times I top and bottom, okay, whenever you would distribute this I through here, you would get 3i right here. And that 3i would still mean you have an I in the denominator, so you would get nowhere. So this is an example where you need to change your line of thinking. Whenever you have two terms in the denominator, bless you, you cannot just do times I or times, whatever. But what you need to multiply by is 3 minus 6i. And you do that on top and bottom. 3 plus 6i and 3 minus 6i are what? We just wrote down not that long ago. No? Starts with the C. You wrote it down. Complex conjugates. There you go. So you need to use your complex conjugates. Alright, for this problem. But after that, it's the exact same. You set it up for multiplication. Set it up for multiplication like that. The top you do what? Starts with D. Distribute. So you get 6i minus 12i squared. The bottom you what? How so? Everybody's favorite four-letter F word. Foil. Foil! Foil the bottom. So 3 times 3 gives you 9. 3 times negative 6i gives you negative 18i. 6i times 3 gives you plus 18i. Minus 36 I squared. Next. Like terms at the bottom. See that? 18i, negative 18i give me 0. What else? Let's kill two birds with one stone here.
Negative 36 I squared would be positive 36.
And?
9 plus 36.
No, not yet. Too soon. What else? Same.
Oh, you want the top one?
Yep.
Negative 12.
Good. Clean up your bottom-like terms. And I squares equal negative 1. Good. All right. Good. So equals 6i minus 12i squared times a negative 1 plus 12 over 9. Now watch me here. Minus 18i plus 18i gives me that 0. 0i. And 0 times I is 0. I squared is negative 1. So negative 36 times negative 1 gives me positive 36. Now look at your denominator. See how there's no more i's? That's what you want. What you really, really want. Okay? That's what has to happen. And the only way that's going to happen is if you multiply the top by the conjugate. Opposite sign. Alright? Add these up here. So you have 6i plus 12 all over 45.
Oh.
And once again, that is almost a good answer. What's going to make that a great answer? Starts with an R. Reduce. What so, Mr. Stokely?
Yeah.
12's too big. Too big. Pretty sure you got to do by 45. Or I'm sorry, the 3. The 3. Someone said 3, I said 45. I don't know what I'm doing. First you got to do by 3. Okay. I don't think 6 goes into 45. Yeah. Okay. So you got to go by 3. All right. But everything's divisible by 3. See that? 6, 12, 45. So divide everything. Yep, everything by 3. So you get 2i plus 4 over 15. And that's a good answer, kids. Alrighty, this last one here. What do you multiply by? No, come on. Not just I. Not 1 minus. 1 plus. Right? Opposite of what you got. Okay? It's got to be the opposite. See how this is minus? That means it's got to be plus. Otherwise, your eyes don't disappear in the bottom. Put that on bottom, you put that on top. Equals. Now set up your multiplication. So 2 plus I times 1 plus I over 1 minus I, 1 plus I. Now this one you got to FOIL twice. Everybody see that? You got binomials top and bottom over here. So you got to FOIL twice now. Okay? Now, when you FOIL them out. So 2 times 1 gives you 2. 2 times I gives you 2i. I times 1 gives you I. I times I gives you I squared. On the bottom now, 1 times 1 gives you 1. 1 times positive I gives you plus I. Negative I times 1 gives you negative I. And negative I times positive I gives you negative I squared. I squared equals negative 1. Go through and change them. So now you have multiple like terms to combine, but I'm going to do that all in one step. So 2 plus 2i plus I minus 1 over 1 plus I minus I plus 1. Now get your like terms top and bottom. So 2 minus 1 gives you 1. 2i plus I gives you 3i. 1 plus 1 gives you 2. I minus I gives you 0. Your homework tonight's page 176. Numbers 15, 16, 33 through 35. Have a lesson check over both days tomorrow.